Today I am going to provide a brief information on thermodynamic temperature scale. This information is very much important. This knowledge is very much essential for thermodynamic calculations. Right. Before entering into this discussion, I wish to recollect or remember the Carnot theorems. Carnot theorem. Carnot theorem 1, statement 1. This is a heat engine, ordinary, normal heat engine. This is a heat engine under reversible condition. Listen, the efficiency of a heat engine working between two thermal reservoirs at constant temperature. The temperature of high thermal reservoir is PHA, temperature of low thermal reservoir is PL. This engine operating between two thermal reservoirs at constant temperature. What about its efficiency? Its efficiency is always less than that of efficiency of a reversible heat engine working between two thermal reservoirs at the same temperature. Clear? Efficiency is always less than that of efficiency of reversible heat engine. This is Carnot theorem 1. Clear? Next, Carnot theorem 2. This is very much important. The efficiency of this heat engine depends only on temperature of thermal reservoirs. The efficiency of heat engine depends only on the temperature of thermal reservoirs. Thermal reservoirs. It is independent of nature and temperature of working fluid. This is very much important. Carnot theorem 2. This statement enables us to design the Kelvin scale of temperature or absolute temperature scale or thermodynamic temperature scale. This statement forms a platform to establish this thermodynamic temperature scale or Kelvin scale or absolute temperature scale. This absolute temperature scale or Kelvin scale point number 1. It is independent of various properties of thermometric substance. What you call the working fluid substance. Point number 1. This Kelvin scale is independent of various properties of thermometric substance. Point number 1. Point number 2. It is independent of arbitrary nature of method of measurement. So Carnot theorem 2 says that the efficiency of a heat engine is independent of temperature and nature of the working fluid. This statement forms a platform to establish or to define Kelvin scale or absolute temperature scale or thermodynamic temperature scale. This Kelvin scale or absolute temperature scale is independent of various properties of the thermometric substance, as well as it is independent of the arbitrary nature of method of measurement. Clear? Okay. The law of Kelvin was established a new property, new information, thermodynamic temperature scale based on the functional equation. How efficiency was calculated for a heat engine? Efficiency is nothing but it is QH minus QL divided by QH. it is equal to TH minus TL divided by TH. On rearrangement, this equation becomes 1 minus QL divided by QH, that is equal to 1 minus TL divided by TH, or I can write like this, those things gets cancelled. Q1 divided by Q2, Q1 by Q2 is equal to T1 divided by T2. This is the heat rejection and absorption. Ratio of heat rejection, ratio of heat absorption. This is the temperature of sink, this is the temperature of source. Okay. This is the functional equation in order to establish this information. That means the ratio of heat content, ratio of heat of source to sink, sink to source is the ratio of absolute temperature of sink to source. Ratio of temperature is equal to ratio of heat content. To define the unit of temperature, the unit of temperature, absolute temperature, the unit of absolute temperature point number 1, if it is possible, that means if an ideal Carnot engine be constructed. It is not possible. If it is possible, constructed, first point. And if the value of Q1 and Q2 are measured, are being measured, then this ideal temperature scale is used to find any of the temperature. Clear? So for example, T1 is equal to T2 into Q1 by Q2. Clear? Now I am going to add one more information. For the unit of absolute temperature, it is used a single fixed point. Single fixed point. That means triple point of water. Point of water. That is 273.16 degree Kelvin. 273.16 degree Kelvin. Listen, in this heat source and heat sink, engine operating between two reservoirs. If one source, that means one sink, if heat sink at a temperature of triple point, heat sink if it is at a temperature of triple point, say for example this is T1. The temperature of heat source can be calculated by heat source. If it is represented by T, the T is equal to T1 into Q2 by Q1. After rearrangement, 2, 1 Kelvin gets exchanged. This T1 is equal to T is equal to 273.16 Kelvin into Q1 by Q2. This is the thermodynamic temperature scale. Brief information on thermodynamic temperature scale. Thank you.